Alright, let's do a sound check as usual. Alright, things seem to be working fine. Hello, welcome to the first in the series of Vulcan streams, where we will be writing some Vulcan code. So I want to first talk about kind of what the stream will be about, what the process will be, what have we been writing, etc, etc. So we will be writing a Vulcan render from scratch. My stream said from scratch with an asterisk. This means that we will not be using any Vulcan libraries, but we will be using some libraries that aren't about Vulcan but help us actually progress. So we'll be using GLFW to create a window. We'll be using GLM at some point to do math, and a bunch of other libraries like this. We'll be using some profile library that I haven't decided on yet, but we will try to write all the Vulcan code that we need ourselves. Depending on how streams will go, I'm planning to basically write all of the code that we have, that we need on stream, but we'll see how it goes. All of the code will be, of course, posted on GitHub. There's a GitHub repository. It's called Niagara. It stands for Next Generation Renderer, which is what we will be trying to do. So I don't want to do like a normal, here's how to draw like a triangle in Vulkan, and then here's how to draw a mesh in Vulkan, and then here's how to use textures in Vulkan. And that's kind of a tutorial-like content. It's not very interesting for me. I'm sure there's like a lot of tutorials out there that do this. Instead, I want to do something that's sort of interesting for me. So what we will be trying to do is we will be trying to write a renderer that is doing as many things as it can do on GPU. We will be doing culling on the GPU. We will be doing potentially triangle or cone culling on GPU. We will potentially be using a new RTX task and mesh shader pipeline if I get an RTX at some point. So it'll be a bit of a sort of hardcore Vulkan renderer, not necessarily something that you can use on every single Vulkan supported hardware, but something that's kind of interesting and that feels like it's the future. So yeah, so the plan is, let's see if that works. So yeah, so the plan is we will have some pipeline that has a bunch of objects. Then on the GPU, we will say only some of these objects are visible. So we will have the objects that are visible. Potentially, we will say one of these objects is a complicated triangle mesh with a lot of triangles. Alright, I will not run the tessellation, and then half of these triangles are not visible, so maybe we can call them more efficiently on GPU, and then we'll be rendering all of this. I want to also try to do GPU-based occlusion culling if we'll have time for this, and in general it kind of depends. I don't know exactly how the series will go. We will write the code that we can, we will see what works and what doesn't. And yeah, we'll try to kind of enjoy the process and then maybe learn something. Some of the stuff that I will be talking about I kind of know. Some of the stuff that I'll be talking about I haven't done ever. So we'll see how it goes. By necessity, we will have to cut corners because we don't have a lot of time, which means that we might be sort of calling out some things that you should not be doing in the production Vulkan code base, and I can talk about what you should be doing in the production Vulkan code base, but we might be like, we will ignore error handling unless an error actually does happen to us on stream. We will start by ignoring some aspects of synchronization, and I'll talk about this a bit later, and in general we'll try to make progress as fast as we can and then clean things up. Also, we are not going to be making a Vulkan framework or a Vulkan like abstraction layer or nothing like this. Our goal is to say, hey, how can you write an efficient renderer in Vulkan, ignoring everything else out there and ignoring parts of Vulkan that don't work on maybe mobile hardware. We will be exclusively focused on desktop. We will start with whatever works on my current GPU, which is Intel HD something, 620, I don't know. And then hopefully in a few weeks we will get us an RTX, and then there will be mesh shaders and task shaders and God knows what else. It's unlikely that we'll actually get to there in a few weeks, but we'll see how that goes. Yeah, and I'll try to sort of mix up the stream between like writing code and talking about how things work in Vulkan and why, and answering questions and all of that. So that's kind of the plan, and to start, we will start our new Vulkan application, and my hope is that we can get to a triangle on screen, which might be challenging, because a triangle on screen is like half of the renderer in Vulkan. But we'll see how it goes. So that's kind of the plan, and let's see. And let's see what the chat says. Try writing it in a language other than C++ for the next challenge. No. So my goal is to experiment with some new Vulkan stuff and to try things that I wanted to try for some time. My goal is not to experiment in a language other than C++. You know, you could have picked Rust or something, but that would just delay the progress unnecessarily. For people who are on Mac, we will not guarantee that the code works. Basically, yeah, like I'll try to use GLFW and some other stuff that should sort of maybe work on other platforms, but I won't use CMake or any of that. Like, the goal is not portability. The goal is to get Vulkan running, to get something cool running in Vulkan, and see how that goes. So if you want to follow along, so the code will be on this GitHub repository, and basically all I will be using is the Vulkan SDK and the Visual Studio. So whatever, like if you're on some other platform, maybe the code works, maybe it doesn't, I don't know. I already have installed Vulkan SDK, so we'll just go from there. And we'll kind of just go ahead and try to create a window and try to draw a triangle. And then I'll talk, once we create a window without a triangle, I'll talk roughly about the sort of Vulkan pipeline that we are going through today, if we get there. And then we'll go from there. So let's go. So we will start by cloning. I'm starting from 0. My repository has one README file that's empty, so I'm starting from 0. And let's just look at this. So I've cloned my repository. There is a README file there. It's amazing. So we will be using GLFW, and there's multiple ways how you can add GLFW to your project. You can use CMake, you can use NuGet, whatever. But we will just go, you know, hardcore and just say, hey, everything that we will be using, all third-party libraries will be just linked from our repository, and then they will just be built as part of our project. That way, if something doesn't work, if something, like if we need to debug something or change something, it will be easy for us to do. So let's create an extern folder, and let's do git submodule init. Great. Git submodule. Alright, this is the time when I I don't add submodules often. Oh, maybe it's git submodule add, that would make sense. Alright, good. So that was good. And we need to create a Visual Studio project. So yeah, we will not be using CMake. I could use CMake, but I don't like CMake too much, and CMake is integrated into Visual Studio, but the integration is kind of not awesome, so I feel like we'll just lose time if we do this, so we will not do this. Instead, we will just create a Visual Studio project. We'll call it Niagara, and we'll have to shuffle some files around after we do this, because the way Visual Studio creates projects by default isn't super nice. Also, it takes it way too long to create a project file. All right. Okay. That's nice, I guess. Oh, it added a precompiled header file. Damn it. I should have just... Alright. So, no precompiled headers. Let's see what it did. Oh, okay. This is not terrible. It could be worse. Alright, so disable precompiled headers. Oh, and yeah, we'll basically be writing 64-bit code because there's no point really using 32-bit in this day and age. I mean, I'll keep the 32-bit configuration, I suppose, in the solution because hey, it doesn't hurt. But it doesn't help. Oh, see out. Oh, right. And we'll be using a console application despite the fact that we'll have a window because I want to be able to log things to the console. All right, so let's clean up after Visual Studio a bit. So I want the folder to be called src. I don't want precompiled headers stuff. And I want... all right. I don't want this file. I want this stuff. Visual Studio should have Git integration. Oh my god. All right. We'll be trying to use that, but come on. Git. How do you do this? Git reset head. It's amazing how, like, it's impossible to remember commands in Git that you need all the time because they're so poorly named. Like, why is... Anyway, okay, this is not a stream where I rant about Git. This is a stream where we write Vulkan code. Alright, so we have a project file. Maybe it compiles. And then we'll have to ignore a bunch of temporary files in Git to make it easier for us to write this code going forward. So let's build this and see what happens. All right, I think we have hello world. We are making progress. Well, technically it's not hello world. Well, I guess it's hello Vulcan. All right, not a triangle yet, but we are making progress. Yeah, I'm not a fan of the folder being here, but I will not do anything with this. So let's just try to git ignore file, where we will ignore, what will we ignore? We will ignore this folder, this, and I guess this. All right. All right, first commit. So now let's try to actually build GLFW and create a window, because we are using a console program so that we can easily print out the status of various Vulkan commands and whatnot. But obviously we're not gonna render a triangle like this. So let's just see if GLFW is a well-behaved library. So for well-behaved libraries, you should be able to just add all of the sources to the project and have it work. Oh, and I'll have to add, I guess I'll need, let's see, so I need all of the Windows stuff. What is Vulcan C? I don't know what this is. Figure it out later. And basically I need everything that's not platform specific. So So let's just add the stuff that seems tangentially related or relevant, and then build it and see what happens. Right, so I guess we need to say that we are compiling a Win32 build. Yeah, so GLFW has some Vulkan support, but it's really minimal, and we will not be relying on this too much. Okay, that's fine. Can I just like add this here? Right, so there's a lot of warnings that are completely and utterly insane. We will not be fixing them, obviously, because they're not in our code. But even if they were in our code, we would not be fixing them. Oh, it edited. I did it wrong. Okay, so let's do this. All right, so that's pretty good. We didn't add, oh, there's some OpenGL stuff that we won't really need. Why is it, so this is, all right. Oh, so you have to, okay, I see. So if you're using Windows, you kind of have to build EGL and WGL and everything. So fine, that's fine. And I guess we need Vulcan C. I don't know what this is. Let's see. Yeah, I don't think we want to do this. Unless GLFW says that we kind of need this code, I'd rather write this code. Oh, we do need Vulcan, and we need OS Mesa. Alright, sure. Fine. Interesting. Yeah, okay. Alright. So I guess it's all or nothing. We need to add Mesa and Vulcan. Why do we need Mesa? I should have just added like all C files. All right, so the code still builds. Now let's, oh, that is interesting. All right, we'll have to pause the stream for a second. I don't know what this is about. I need my keys. I'm totally not able to do this now, sorry. Alright, this is what happens when somebody gets a delivery and it's not me, and whoever gets it is not home. Let me look at chat to make sure that things work. Maybe have a look at Molten if you're on Mac. Yeah, so Molten VK looks pretty well on Mac. I covered the end goal. Why not C instead of C++? I'll talk a bit more about this. Deps, Vulcan C, C++, Amazon time. Yeah, it's not even my Amazon time, it's somebody else's Amazon time. Would have been easier on CMake. I don't know if that's true. I just added a bunch of files that worked. I just didn't know which files to add. Anyway, it would have been easier with CMake, but there would have been some other issues with CMake. And also I will be adding some third-party stuff later that may or may not have CMake support. And if it doesn't, I'd have to add it, and let's just not go there. Alright, so let's create a window and then see if that works. And then if that does work, then we will actually talk about Vulkan. So I wanna add so this is basically, yeah, I want to add this folder to the include path, and then I can include GLFW this. And I don't work too often with GLFW, let's just wing it. Well, I guess it's monitor. Right, share. I should have really. Oh, so the other thing that I want to do is I want to be lazy, and I want to just not do error handling much. And in order to be able to do that, I will just. Yeah, let's do this. Why does it? Oh, all right. So let's just enable assertions. Basically, I don't need this macro. I don't even need this macro. I don't know what this is. All right. So this will make sure that assertions are compiled in and release as well. So we can just like not worry about this stuff for now. And then if we need to worry about this stuff later, we'll worry about this stuff. So yes, I should probably read some GLFW sample. I don't use it very often. There's like GLFW poll events. I don't know, should I show the window? Should I destroy the window? I don't know. Oh yeah, now Visual Studio has to rebuild everything because we added an include path. Alright. Oh yeah, you have to call GLFW init or something like this, I think. Alright. Come on. What does it return? Is one good or bad? Alright, it returns GLFW true. This is the like benefit, I guess, of having. I guess with CMake I would have gotten the same thing, but I tried using GLFW through a NuGet, and it's like a pre-built binary, so I can't just go into GLFW source and look at what's happening. But okay, so I guess it doesn't return error code. Alright, so we have a window, and we can't close the window. I think there is GLFW should close. Is there? No. Alright, whatever. Let's just leave this as is for now. No. Go back here. Should... Alright, let me cheat and I will look at the other thing that I was... Yeah, GLFW window should close. Oh, I was... okay. Alright, hopefully now we can close the window. I don't think we need to terminate GLFW. Why does it rebuild everything again? What did I do? Alright. Alright. Let me just make sure that... So I changed the CPP file. Alright, good. All right, so we have a window. Now let's talk about Vulkan. So when you use Vulkan, and this is kind of touching on, there was a question in chat about C versus C++. So I will be using C++ because I find some minor things more pleasant to use in C++. However, it won't be like hardcore C++ with like a lot of classes and templates and whatever. It will be like a sort of C like C++. When we use Vulkan, in theory, you have two options available to you. You can use the C++ headers for Vulkan or C headers for Vulkan, and I will use C headers for Vulkan. It's a personal preference, or it's a personal preference that's motivated by sort of technical quality, I should say. So if you look at C headers, then they are 400K, all of them. Well, I guess maybe that's not true. I think some of these, well, whatever, these are like small. So this is roughly all of the C headers in Vulkan. So this is like 400K. So one Vulkan C++ header that I believe includes all of the C headers is like 1.8 megabytes. So that's quite a bit larger. It also takes quite a bit longer to compile with this header included. And I don't feel like it provides value, honestly, or that much value, enough value to be useful. And also a lot of the documentation that you might see on the web, a lot of tutorials, they don't use this. So it feels like this header just introduces unnecessary fragmentation, so we will not be using this. We will be using vulkan.h. Speaking of vulkan.h, so yeah, I installed the Vulkan SDK. We will not be including Vulkan SDK as like a GitHub submodule. We could, I guess. I guess we could. Should we? There might not be lib files in the GitHub thing. So I guess, yeah, we probably won't. Let's just use Vulkan SDK directly. Now, so if you're using a production problem, if you're using, sorry, what am I even saying? If you're writing a production Vulkan renderer, you might not want to use the Vulkan SDK directly for a couple of reasons. One is that using it generally means that you link your application to the Vulkan runtime, and then if Vulkan runtime isn't available, then you can't easily fall back to a different renderer. Now you can solve this problem, but there's also some performance caveats. So normally I would use my own Vulkan library, which is called Vulk, which is a meta loader for Vulkan. The only reason why I will not use it on stream is because I said that we will not be using other Vulkan like third-party stuff, and this is sort of third-party Vulkan thing, right? So, and it's not part of Vulkan SDK, obviously, right? So I guess it's not okay to use it, so we will not use it. But normally I would just use this, and then I could just put this to GitHub and then put maybe Vulkan headers to GitHub, and then it would be completely self-contained. You wouldn't need Vulkan SDK to build necessarily. But since we'll need a shader compiler to build our project, because we'll need to compile shaders from source, we kind of need Vulkan SDK no matter what. So let's just assume the only problem with that is that I'll have to hard code a path to like Vulkan SDK that we use in the project file. Because right now, if I do like include Vulkan, it doesn't do anything, right? So there's that. So that's not great, but we will survive, and then maybe at some point we will clean something up. But for now, I will just, oh, is there actually, wait, maybe I'm doing this wrong. Is there, oh, okay, never mind. We will not have to hard code this because there is the environment variable for Vulkan SDK that we can use. So we'll just say that we add Vulkan SDK include to our include path. So let's see if that works. All right. So as I said, we will be using this header. There's also this header. Just as a just as a point of curiosity, let's see. So let's do this. 1, 2, 3. So it takes like 3 seconds. 1, 2, 3. It takes like 3 seconds to compile this CPP file. And it takes like half a second or something to compile the CPP file with the C headers for Vulkan. This is why this is one of the reasons why I don't like the C++ Vulkan header. It's just too large, it's too bulky, it's useful, but it's not that useful. So we will not be using that. All right. So let me stop coding for a bit. I will look at chat, and also I wanna kind of talk a bit about the Vulkan initialization sequence that we will be writing code for right now, before I start actually doing this. Also, can I unroll this chat somehow? Oh, there's like a pop-out somewhere. All right. Maybe that will make it easier to read this thing. So yeah, so why not C instead of C++? I mostly covered this. I'm a bit more comfortable writing C++ code. I usually write C++ code that's really close to C, but it's not exactly C. What do you think of Anvil framework? I have not looked at Anvil framework. It's probably good. This is NVIDIA's one, right? Yeah, I haven't looked at this, but they use it internally for research. GLFW can create a Vulkan window surface for you. Yes, we might use that or might not use this. It's like 5 lines of code, so we might not use that. Vulkan's really good. It would be great to see it as part of Vulkan SDK. Yeah, it would be nice. So Vulkan technically violates Vulkan specification as far as I remember. There is like this weird bit in Vulkan specification where you can't really declare a symbol in global namespace that starts with VK, because it might conflict with future releases, and Vulkan solves these problems on a practical level, but I think, yeah, I don't know. Anyway, yeah, it would be nice if it were a part of Vulkan SDK, but you can just use it. 20 lines, let's take a break. Yeah, so I kind of know what I will be doing now, but not all people on the stream will, so I want to talk a bit about Vulkan initialization. So the way Vulkan works is that most of the operations that you need to do, they involve a Vulkan device in one way or another. So you kind of need to get to the Vulkan device. But to get to the Vulkan device, there are several steps that you have to take. So, what we want to create a Vulkan device. What we need to create a Vulkan device is we need to pick a physical device. Physical device corresponds to a GPU. Like if you have 5 GPUs, hope you don't have 5 GPUs, but if you have like 2 or 3 GPUs, which can happen, then generally there's a physical device per 1 GPU. And then from a physical device you can create a logical device or just device, and there's a reason why this separation exists. Like for example, if you have an SLI system with 2 NVIDIA GPUs, you could create one device, you could create 2 devices, 1 device per GPU, or you could create one device that kind of corresponds to both of them, and then you can submit some commands to both of them at once and some commands to just one. This is, I think, parts of this feature are new in Vulkan 1.1. So there is a reason why the separation exists, but the more important thing is that when you create a Vulkan device, you have to pick the correct physical device that you want to use. Very, very loosely, if people who watch this are familiar with Directory 11, very, very loosely, this corresponds to device, and this corresponds to adapter. It's not quite precise, but close enough. And so to start creating device or picking physical device or do other things like this, we need an instance. You generally have just one instance in a program, although if you have some complicated setup where maybe you are integrating with Qt, and Qt for some reason decides to use Vulkan, then maybe they want to create their own instance. But generally you only have one instance in the program, and instance is kind of your interface to everything Vulkan. Before creating an instance, there's like 2 functions that you can call. One is create an instance, and one is get the version of the loader or whatever. Instance corresponds to Vulkan runtime or Vulkan loader, to be more precise, more or less. So, for example, you might have different GPUs installed on your system. You also might have different programs installed on your system that try to integrate with Vulkan applications. For example, we will be using Vulkan validation layers that are a set of DLLs that can sort of be added to your program whenever you create an instance. And the Vulkan loader is the part of the system that manages all of this. It's generally just a DLL, so it should be installed in the system folder, hopefully. Yeah, so as you can see, I have two DLLs. One is Vulkan 1 DLL, and one is Vulkan 19900 DLL. I think this is a weird way to deal with some backwards compatibility concerns or forwards compatibility concerns, but whatever. Yeah, so basically this DLL is the loader, and this DLL is mostly what you talk to when you create an instance. And then once you create a device, that mostly goes to the driver or to some other layers that you may have in the system. So we have to create an instance, we have to pick the physical device, and then we have to create the device. Now, the other thing that we need to do, once we create a device, we could start submitting GPU commands once we create a few other structures that I'll talk about later. The other thing that we will need to do is we'll need to draw something on screen, right? So for that, we need to create another thing that I think is created from the instance, or maybe from physical device, which is called surface. And from surface, you can create swap chain. So this is loosely so this in DX terms is loosely swap chain, same thing, and surface in DX terms is loosely, I guess, DXGI factory. It's not super precise once again, but it's close enough. So swap chain is the thing that you can render into. Swap chain has, or rather it can give you images that you can render it to. Swap chain has a size, right? So if you have a window that's 1024 by 768, swap chain can be 1024 by 768. If you're resizing the window, you need to destroy the old swap chain and create a new swap chain for the new window size. The surface is the thing that can manage all of these interactions and actually give you a new swap chain. And the surface is tied to the window handle, which we should be able to get from GLFW. And yeah, that's kind of the basic structure that we'll have to start with. So you can see, so we'll need what, like we'll need 5 objects. This is not enough yet to render a triangle. To render a triangle, we might have to have 5 to 10, probably like 10 more objects. But let's start with this. So we'll initialize Vulkan, pick the physical device, there's only one in my system, and then create a device, and then create a surface and create a swap chain, and then go from there. If you had an internal GPU and discrete device, could you choose which one is used? Yes, we will quickly go over this. We won't have much of a choice, but we'll quickly go over this. Alright, oh, something that I forgot to mention on stream. So I guess I did say that I am not going to create like Vulkan abstractions or whatever. I will be mostly just writing code, and then when the code becomes a bit gnarly and a bit hard to deal with, we will refactor this as we go. This is loosely related to the term semantic compression. There's an article by Casey Muratori about this. I recommend you read this. It's a good article. It's kind of a different way of how to work with code compared to what you might be used to, or what you were taught in high school or university or wherever you learned how to program. So yeah, we'll kind of just be writing code, and then once code becomes too painful to deal with, we'll make it less painful to deal with, and we'll remove a printf. So alright, so to create an instance, we need to call vk create instance function. Maybe I'll learn to type better. Most of the code in Vulkan. Should I start using? Yeah, that's fine. So most of the functions in Vulkan, they don't take a bunch of parameters, they take a bunch of structs, and then you have to fill the structs. So this needs a create info, and then this needs allocation callbacks, which is kind of a thing that we will not use. It's not often useful. Not all drivers even implement it well. And then it returns as an instance, and it actually returns via the C return value VK result, which we have to check. And remember, we are not doing error checking, so oh, the only thing is, so something that we will need a lot is, let's just define this. We'll define a vcheck macro, because there's a lot of functions in Vulkan that return a result. And I don't want for every call for these to like manually check that. So we'll just do this. I think Visual Studio. All right, and we'll just assert that result is VK success. Come on, stop formatting my code when I don't need you to. Right. So now we can basically just say vk check, vk create instance, create info 0, and then instance, and then if the call fails, then we will deal with that at some point. Obviously, if you're writing a production Vulkan renderer, then you will have to handle some of these. Like this can fail. If it fails, it just means your system doesn't support Vulkan. So instead of asserting, you should probably either tell the user, hey, you need Vulkan drivers or Vulkan compatible hardware to run this, or you should switch to OpenGL or Direct3D or some other API that you use. But we will not be doing this to save time. So yeah. So let's briefly talk about how Vulkan structures work. Most of them, for reasons that have to do with being able to extend the API with extensions, have the same structure. There is a type of the structure, that's the first field, and it has to be the specific value, which is the enum corresponding to the type of the structure. You may be familiar with this from some other C-like APIs. Win32 API does things that are sort of similar but slightly more obnoxious, where often the first field in the struct for Win32 API is the size of the structure. But anyway, yeah, so then there's this pnex pointer that basically has to be null. It can not be null, but I'll not cover this up until we get there. And then there's stuff that you can fill. Some of these are optional, some of these are mandatory. So we will, great. Oh, this is like, I see, this is for compatibility. What is Kazan? All right. Something that I forgot to mention is that when you write Vulkan code, you kind of have to have the Vulkan spec open, basically most of the time. The reason is there is subtlety in Vulkan API that is easy to miss if you just look at structures and functions, and it's kind of good to be reading the spec as you write code to make sure you haven't missed anything. So we have it open. Spec is a very, very, very large HTML document. There are some versions of the spec that are split into pages, but this is the full spec. This is the full spec of Vulkan 1.1 with all extensions. So I think by now this might have RTX extensions, or maybe not. It depends on when this was published. So yeah, as you can see, there's a lot of text here. You're not supposed to have read the entire spec, although I highly recommend that if you actually are serious about Vulkan and want to ship Vulkan code, like have a Vulkan renderer in your next large title or whatever it is, you should probably read most of the spec. It's still scrolling. Should we wait till the end? It's getting close. The size of this is slightly misleading because this is all extensions. Like the GL spec does not include extensions, for example. but it's still pretty big. All right. Suffices to say, we will not be using the entire Vulkan API in these streams. It's just too large. All right. So yeah. So the way I usually deal with the structs is I initialize them with the correct enum value, and 0 initialize everything else like this. And then I just fill things that I need. And in here, I only need this stuff. And I will need some of these now, and I will need some of these later. So when you initialize the Vulkan instance, you can say that you want to enable some layers. For example, we will be enabling validation layers that help us verify that the code that we write is actually correct. So layers are DLLs mostly that are injected into your program. And then you can enable some extensions. And extensions are used to allow you to use some functionality that's not present in the core spec. If you are used to OpenGL, you might be used to saying, hey, just like pick an extension and use it. In Vulkan, you have to upfront declare every single extension that you might be using in the future. This is actually valuable and important because this means that there's never surprises that you don't know about, because if a device doesn't support an extension, creating an instance will fail, right? So this prevents situations where you use an extension somewhere deep in your rendering code and everything works, and then you test this on some configuration that doesn't have this extension, and you've forgotten that you use this extension in the first place, and then it doesn't work. And there are some other subtleties about extension enabling. Some of them actually can change the behavior of existing core APIs. But yeah. Oh, yeah, so we will still need... Alright, yeah, so we will need application info as well. We will need application info because we want to create a Vulkan 1.1 instance. We might not be using Vulkan 1.1 stuff much right now, but... Oh, this is assuming that my Intel drivers actually support 1.1, which I'm not sure about. We will find out. Make version. Oh, is there like a Vulkan version? Yeah. So I want to leave comments. I want to start leaving comments in the code that are kind of like, this is a shortcut. This is something that we are not intending to fix necessarily, but this is something that you should not be doing in production renderers. So shortcut. In real Vulkan applications, you should probably check if 1.1 is available via, there's a function vk enumerate something something via this function. But we'll just say, hey, 1.1 is always a thing, hopefully. It's not actually true, but it might be true for us. All right, and then I wanna set up some code to just support enabling layers. There's a slight problem with. Let's just create something, see if it worked, and then we'll do the rest. And then we need to destroy the instance at the end. Also, we'll find out. Oh, I guess, yeah, this will succeed because my loader has 1.1. All right, yeah, and now we are actually using Vulkan, so we will need to link to something. This is like a really long list. I'm pretty sure I'm not using half of this, but okay. So so we need this library, and I guess there's a 32-bit version. I don't really wanna be testing the 32-bit stuff much, but maybe I should still do due diligence and try to make sure it works. So for 64-bit, we basically need this. And for 32-bit stuff, we basically need this. All right. So nothing is broken. We have created a Vulkan instance, and that's good. Now the thing that I want to do immediately is I want to enable validation layers in debug, and I have removed the debug configuration macro, so that's not going to make it very easy. So let's just add it back to debug builds. Validation layers slow down your program, but they are indispensable if you want your code to actually work. So we will say that we need layers. So yeah, this is what I wasn't sure about. The problem is C doesn't let you have arrays that don't have elements in this. We could just use stat vector, but using C++ so early in the stream feels wrong. So I don't remember how the validation layers are called. So let's just Google this. It's like lunar G something something. Lunar G standard validation. Oh, I guess we will not use any other. Yes, I guess we can just say that debug layers. And we'll just say that if we are in debug, we will just add them to I mean, it's technically just one layer, but maybe we'll need more in the future. So there's that. Oh, right, and the other thing that we might as well do just now. So I was talking about the surface stuff, that you need a surface to be able to render into the window. Surface is not a core object, it's an extension. So we'll have to enable an extension, like right now, to be able to present anything into our beautiful window, which is interesting, but whatever. So it's like vkchr surface extension name, which is vkchr surface. I'm not sure why they have these macros, because it's not like you can actually change this value after the fact, but whatever. I can't type today, so yeah, this is that. As you may be starting to see, Vulkan is a bit of a verbose API. Oh, I forgot to do a GL thing. Should I do a GL thing? Whatever. Somebody on Twitter said that they want to troll me in chat by posting code that's sufficient to draw a triangle. We have hit our first validation error, by the way. Alright. Yeah, that like you can draw a triangle in OpenGL1 or something in like 3 lines. And I was thinking of doing this on stream, but whatever, I will not waste time doing this. So, what the hell? Oh, fantastic, fantastic. Okay, this was wrong. Never mind. So this is why validation layers are useful, right? Like this code worked perfectly without validation. Like we created an instance without problems, but this code was broken because I used the wrong enum. It's not even an enum, it's like a define. So, alright, so now our code works. So that's great. Oh, and yeah, the validation layers printed the error in the console, which means it's helpful to have a console window. Alright. So now we should be ready to create the device, pick the device, and all of that. So let's go there. So we need a physical device, and then we need to create the device from this. So there is a function vk enumerate physical devices. This function is in typical Win API style. You should call it twice. You should call it once to figure out how many you have, and then you should call it another time to figure out which devices you have. But we will be cutting a corner by saying that if you have more than 8 physical devices, can you put more than 8 GPUs? Okay, if you have more than 16 physical devices, we will only pick one of the first 16. This feels like a fine compromise to simplify our code. So yeah, we'll say that there is like at most 16. Oh, IntelliSense is interesting. Okay. And remember I said like you need these instances and devices to do everything, so yeah, you have to pass all of these pointers explicitly into every single function. So Vulkan API is verbose but explicit. Explicit is nice. Physical device count, physical devices. Oh, and you have to initialize this guy actually to 16, so... I should just make a macro for this, but whatever. Alright. So now we have a bunch of devices, and device is just a pointer. It's not like, it doesn't mean anything. So we can say get physical device properties, I suppose. That will return us a struct with the name of the device and the vendor ID and whatever else. IntelliSense is not very fast today. So you can get a struct that tells you things about the physical device, right? So at this point let's just write a function. Well, yeah. Oh. It's hard for me to write the word physical. I don't know why. Alright, so you might have more than one GPU, and we only have one GPU, but you might have more than one. And if you have more than one, you have to make a conscious choice of which one you need. Maybe I'm just bad at typing today. So there's not a really good way for doing this necessarily. There's not like a standard way of doing this, but what we will do is that we'll go over all devices. We will look at... So let's say, yeah, so what we'll do is we'll just pick the first discrete GPU if we have one, and if we don't have a discrete GPU, then we'll just pick the first GPU period. So we'll go over all, and for us, we'll actually don't have a discrete GPU right now, so we'll end up picking our integrated GPU. Yeah, okay, so we can get physical device properties. This function can never fail, so that's good. And then if props device type is vk device type, vk physical device type discrete GPU, then we'll just say, hey, picking discrete GPU device name. If we haven't found one, then we'll just pick the first one. If there is one. It is possible for the device count to be 0. This is relatively standard actually, so creating an instance just means that you have Vulkan runtime installed in the system, but you can still have no drivers that support Vulkan, or GPU doesn't support Vulkan, or... let's call it fallback. Oh, damn it. All right, let's just query it again. It doesn't matter much. And otherwise, we'll be like, hey, no physical devices available. So there is a like null handle for every Vulkan API, which is null handle, but also it's 0. And I don't like typing much, so we'll just do this. And then we will not actually do error handling here. You would exit, you would either show a message to the user and exit in this case, or you would fall back to a different renderer. All right, let's run and see what happens. All right, so we don't have a discrete GPU, and we only really have one GPU in the first place. So we're picking the Intel. Let's do this and this. All right, now we need to create a device. To create a device, you call vk-create-device. So you need the physical device that we have just picked. You need create info that we'll fill. We need 0 as allocator, and we'll get device. And we'll need vk check around this. So most of the vk checks that I'm writing are basically things that you'd have to handle in the production renderer. Let's do... so the code begins to get unwieldy. So let's start refactoring this a bit, because I want like shorter names for variables. So let's just say that we'll move all of the code that creates an instance into here. And keep going. Well, right, so now we will need create info, and we'll have to move device initialization out at some point, but whatever. So let's see. Oops. What do we need to create? Oh, all right. Do I need to pass this thing to... Oh, is this the deprecated stuff? Device layers have the deprecated device layers. The problem with the Vulkan spec being really large is that browsers aren't very fast. Maybe they haven't. Alright, let's ignore this for now. I don't know if I need to do anything here. I think I will need to... I may need to do something here, but let's ignore this for now. Ignore this. We will need this, unfortunately, and... Alright, we will not need this. Yeah, so when you create a device, you are supposed to say which device queues you need, and we will not go over device queues right now. Oh, do I really have to fill this in? I think I do. Yeah. So this is another place where we'll cut corners, because I don't want to do the correct thing right now. You're supposed to... A device can have multiple queues, and each queue can be used to submit commands. But you don't know which queue you need without looking at what queues can do. Like, there could be a queue that only can do compute, and there can be a queue that can do graphics and presentation, and there can be a queue that can only do copy. Technical compute queue can also do copy. And you're supposed to kind of look at the device properties and figure it out, but in the interest of getting something going, which we probably will not get to anyway, but hey, we should try. We'll just say that, right, yeah, so that's 0. We'll just say that we'll assume that the family index is 0. Shortcut, this needs to be computed from queue properties. And then maybe we'll get to it, or maybe we won't. Like theoretically, 0 might not correspond to a queue that can do anything useful on some GPUs. And then it's weird that you have to fill some of this stuff. Like, it's just, it's not, I don't feel like I'm doing useful work right now. But okay, whatever. Alright, so create info queue, create info count, create info queue, infos, queue info. So we might have a device now, especially if the code compiles. Oh, this is valid C++. C++ is an amazing language. Maybe I should have used C. All right, what do we have? Oh my god, oh no. Our shortcut didn't work. The validation layers insist on us doing the right thing, which, I mean, is good, I guess. But it's so painful. So yeah, they want us to get like, to examine the queue properties before actually picking this as the queue that we will use. Because they say, hey, if you haven't ever looked at the queue, then you're using a shortcut. Shortcuts are not nice. I really don't want to deal with this stuff. Like, I might deal with this stuff at some point, but I don't want to deal with this stuff now. Okay. Should I ignore this? I don't want to ignore errors. Let's just ignore this for now. So this is something that we'll actually have to fix because I want to be validation clean, but I don't want to spend time on this right now. Alright, so we have created the device. Now we need a surface, and then we'll need a surface, a swap chain, and then we can we do anything with the swap chain? Yeah, we can't do much with the swap chain. So we are not close yet, but we are making progress. Let me look at chat. Yeah, device layers are deprecated, that's what I thought. Which MS surface are you using for Vulkan development? This is streamed from a Surface Pro. Vulkan works on it if you install Intel drivers from the Intel driver website. It does not work if you just use Windows Update. Ligma hardware, I'm not sure what that means. Thanks for Vulkan Metal Loader, you're welcome. What do you think about VEasy? I am not a fan of VEasy. It's a good idea, but they are redefining the meaning of existing Vulkan concepts. Like they have a VK buffer create info that is not VK buffer create, VK create buffer or something that matches the name perfectly to the Vulkan VK create buffer, but it doesn't do the same thing at all. It doesn't even have the same interface. So yeah, I'm not a fan. Oh, is it possible to write 1080p stream? I don't know. Oh, I looked at this before, and I thought the stream was 1080p, but it somehow wasn't. But I don't know if I can switch it now. I should have looked at this before. What happens if I change the streaming resolution, like mid-stream? I don't even remember where it was. Oh yeah, I guess video output is currently active. Yeah, it's my bad. I should have done this before. So we'll do this next time. You can get a black window with swap chain. Well, yeah, I guess there's that. Clear color, yeah, no, so for clear color you need to do a bit more. But yes, so we will get to a non-black window probably earlier. What does Vulkan interface with? Try to understand what Vulkan is built on top of. I guess I don't really understand this question, but mostly it interfaces with the graphics driver. It doesn't... The stuff that I'm doing now, so like from VK create device and there on out, I'm just talking to NVIDIA graphics drivers plus the validation layers. There is nothing else really in between, I don't think. All right, let's do the surface stuff. So yeah, I think somebody was mentioning that GLFW has a function that creates a surface, but technically I'm not allowed to use it because it's like part of GLFW. And if GLFW has get platform, get window handle or something like this, which it should, I just no, yeah, okay. Then we'll just create the thing ourselves. I guess the problem is if we do that, we will not work on any other platform. And if we don't do this, you know what? Maybe let's just create. Oops. Yeah, so there was like some Vulcan stuff. Let's see. Yeah, so there is this guy, which basically abstracts the stuff that you'd have to. You know what? No, I kind of wanna. Yeah, so get Win32 window. I kind of want to just write the code that you would have to write regardless of whether you use GLFW. So we will say that if def vk platform, great. Oh, use Win32. I don't remember use platform. Oh god. Okay. Let's go and look at this code. So most of Vulkan code is cross-platform. The only exception is, the major exception I should say, is the code that creates the surface. Unfortunately, there's different extensions for this and they're basically all the same. So that's not very nice. Do we have to define this? I think we have to define this ourselves. So there's that. And then okay, so we need to create a surface, and to create a surface on Windows you do create Win32 surface khr. You pass it an instance, you pass it create info as usual, which is the point where we'll make a function right now. vk surface khr. So yeah, this is the function that is available in GLFW, but if you don't use GLFW, then you can't use the function, right, obviously. So we will do this. And this is where you would add support for Linux or Molten VK or, you know, I don't know what else. Nintendo Switch. Alright, oh yeah, and we'll need an instance. This is like the only really platform-specific part that you would need to write for most Vulkan applications, which is nice. Surface, return surface. And yeah, so we'll need a create info, Win32 surface create info. So yeah, if we used C++ wrapper, then the big thing that it saves is it saves typing on these things, which I don't consider worth it, but if you consider worth it, you know, who am I to tell you what you should or should not be doing? So we need an H instance which can be retrieved by doing this on Windows. And we need HWind, which there was like GLFW. What was it? Win32 get. I already forgot. Get Win32 window. Is it a thing? It's not a thing. I might need to include something to get this thing. Oh. Oh, right. I don't have. Visual Studio is not helpful. GLFW3 native. Alright. That I can do. So this code becomes cross-platform. That did not work. Oh. Oh. Okay. I guess I need more defiance. More defiance. Oh, did I? All right. Let's. I think I didn't. Alright. Does this work now? Alright. So yeah, so basically this piece of code is the piece of code that we valiantly ignored the existence of in GLFW, and assuming this works, we got the same thing, but now, alright, this does not work. Alright, we forgot to do something. Oh, yeah. Oh, yeah. I forgot about this. Yeah, right. This is like a device extension. Alright. I'm at the point where I want to extract this code. So this is how device compression works, right? Semantic compression works. You sort of write code, and you're like, this code gets ugly. Let's just move it out. And it's really easy to do that. In some cases, in some software programming like environments, this is called extract method or something. But really, you're just moving code to functions. All right. So there's that. All right. So the reason why the code didn't work is because this function is part of the extension. I forgot that it's not part of the extension that we have already enabled, which is this one. It's part of a different extension that's Windows 32 specific. And my recollection is that it's a device extension. So in Vulkan, you can enable extensions on an instance basis and on a device basis. Device stuff goes, I guess, more directly into the driver. There's like reasons for why some of this stuff is done this way. Like, I don't know if the problem is the loader has to know about the extensions that you can enable through it, as far as I know. So I guess if we are dealing with something like RTX, where there's new NVIDIA extensions, you can't really enable them in the loader because the loader doesn't know about them, but you can enable them on device because the device does. I don't know. Maybe there's a different reason for some of this stuff. I am a bit fuzzy on some of these. No, not spec version. Extension name. I'm also really hoping that validation layers thoroughly verify this. So normally, I guess I was talking about this before. So it must not be, it must be device extension, but then why? Interesting. All right. Sorry, it must be like an instance extension. Oh, I guess right. Sorry, I'm being stupid. It cannot be device extension because we haven't even. All right, never mind. So it cannot be device extension because device extensions work with things that you need a device for, and to make a surface you don't need a device, so it cannot be a device extension. I don't know how to format this. Oh no, wait, this is all good. Okay, this might work. So we still are getting this error about the Q family stuff, and it would be nice to clean that up. It kind of depends on whether I think we can get to something on screen today. Maybe, so I don't think we can get to triangle on screen, and I figured we wouldn't be able to, because I will need a shader to render a triangle. But we should be able to get to like a magenta screen, hopefully. Even that's a bit of a stretch. All right, let's write a bit of code, a bit more code, and then see where we land, and then maybe I'll fix the validation thing before we stop. Yeah, I do need to include GLF3 native, GLFW 3 native, and then turns out I also had to enable some macro for this. All right, so yeah, so we have created a surface. Now we need a swap chain. So to create a swap chain, we need to do create swap chain, I guess. And so surface is the thing that manages swap chains, and swap chain is the thing that knows a specific size and stuff like that. Swap chain management in Vulkan is tricky. I might not, you will notice that I'm mostly not looking at the spec. So normally when you write Vulkan code, you should be looking at the spec, looking at what it says, and then like writing code based on that, and then maybe look at some tutorials, although tutorials are not always correct. Even really widespread tutorials. There's like bugs in some of them, so don't assume that just because the code is in some tutorial on Vulkan, the code is perfect. You should read the spec, try to understand the spec. If you can't understand the spec, then I don't know, you can ask people who you think might understand the spec. Oh yes, so the device extension is for swap chain creation, right? Right? Is that right? vkchr swap chain, yes. All right, so yeah, I guess I need that. Right, I remember that there was a device extension that you basically need all the time, but I didn't remember what it was, so I guess it's this one. Oh, and I'll just copy this code. All right, so create info 0 swap chain. There's this weird naming stuff about basically a lot of words that look like they're two words, but they're actually one. So swap chain is one word, which is why C is not capitalized. Frame buffer is one word, although a lot of people spell it like this. A physical device is two words, so go figure. Alright, so yeah, so we'll need, and so the swap chain is something that you'll have to recreate when the window size changes. We will try to not do this today, because it's more code, and you know, code is painful to write. Oh, yeah, swap chain counter. Alright. I have not seen this extension before. Why does it? Really? Really? Oh, X'd? What? Okay. All good, never mind. Alright, yeah, so this guy has a lot of properties. So this is where we will look at the spec and, you know, I'll look at this stuff. So yeah, this family index thing we will need later. So let's just say that if you're writing a Vulkan application that is really advanced, you might want to use multiple queues, in which case you need multiple queue indices and multiple, like a lot of these things. There are reasons for why you might want to do that. We might get to that at some point, but definitely not now. Alright, so now let's look at the spec, I guess. I don't know. Well, I remember most of these. And some of these are slightly tricky to deal with, and we'll be cutting corners. So maybe I don't... Let's just wing it, and then we'll see how we did. So I don't need flags, I do need surface. Oops. So yeah, remember, all of these structs are 0 initialized, so everything that I haven't filled is just filled with 0. So min image count. So when you create a swap chain, the swap chain will manage several images for you, and an image is just an array of pixels, essentially, but it's visible to the GPU. You generally need a double buffered setup, so this is what min image count is for. It says I need at least 2 images or buffers. Well, buffer is like the wrong term, but in Vulkan buffer means a different thing, but in double buffer context, buffer means the same thing, so whatever. So yeah, image format. So this is a thing that will determine what you use to, what format you use to render into the surface. So some devices, and I don't know what Intel does, but some devices only support BGRA output, not RGBA output, so you have to kind of figure out which format you should use dynamically. And I think the same thing, color space. This is like a wrong enum. No, this is the right enum. Yeah, I need this guy. Wait. Yeah, I think I need this guy. I don't remember if this is guaranteed to be supported, but I guess it's the only enum entry that is not like crazy high numbers. So I guess it must be guaranteed. Image extent is the size of the swap chain. And it has like width and height probably. So this will just fill with image extent. GLFW get window width. Is that a thing? Get window size. Okay. All right. IntelliSense works really weirdly with this partially written code. All right. So there's that. So this basically, these parameters tell the driver, or not really the driver, but tell Vulkan how you will, like what parameters do you want the images to be created with. So the size is pretty straightforward. There are some use cases where you might want the image to be a texture array, but we definitely are not gonna do that. And then you have to say what are you gonna do with the swap chain images. So we will render to the swap chain image, which is this thing. You can do other stuff with the swap chain image. So like maybe you want to copy things to the swap chain image with this. We will not be using that. So there's that. This is for cross-process sharing. We don't need this. Just don't fill that. So yeah, this is the weird, like, I wish I didn't have to fill this. But there we go. Oh, yeah, family index. This is all not useful. Present mode is this is for whether you need vsync or not, or there's some other values here. We might need to. I think Pfeiffer should be guaranteed though, so there's that. All right, we might be done with that part. Oh, so validation layers have been difficult again. It feels like whenever I say that we'll make a shortcut here, validation layers say no, you have to do the right thing, which is nice. So it tells me that this is the thing I was talking about. Not like there's not a single format that is guaranteed to be always supported. So you have to always check which formats are supported. So you have to call this thing. And then it complains about some other stuff. Oh yeah, and it tells us that you have to check if the physical device actually supports rendering into the image, which we haven't checked. All right, whatever. We will clean this up later. The code works for now. You should never ship the code with validation errors. And if there's ever a bug in the code and you have validation errors, you should probably fix them first. But there's no rule that says that you can't ever write code with validation errors. You just shouldn't ship it, right? We'll fix it later. All right, so I might be able to. Can I present now? I might be able to present. Is that true? I don't remember. Oh, I'll need the queue. Well, device swap chain. I think I'll need the semaphore. Yeah, so I think I can basically write a loop here. All right, so how much work will it be for me to actually clear? Is there vkcmd clear? No. Oh, but vkcmd means that I'll need to. So I guess there is this guy. But I'll need a command buffer, and to make a command buffer I need a command pool. Alright, we'll probably just not get to to this today. I'm trying to figure out if I should be fixing validation errors or if I have a reasonable chance of getting something on screen that's not a blank window. You know what? I think we can try it. Yeah, maybe we can try together. So let me look at chat, and then I will. Yeah, so FIFO is guaranteed. Mailbox. There is like a reason for why you might want to use Mailbox, but there's also reasons for why you might not want to use Mailbox. So mailboxes. Yeah. How large is the Vulkan code base? I guess I don't know which code base you mean. So if you can be more specific, I can maybe answer this. Yeah, so I can use, I was planning to do device wait idle. I think I still need the semaphore, but I don't need some other stuff. So yeah, so let's try to do this. All right, so we have a swap chain, so that's nice. Now what we need is to present the swap chain to the window. So we need to, for each iteration in our loop, we need to say, first, let's get the image from the swap chain that we can render to. Then ideally render something to that image, because otherwise I don't know what you're doing. And then tell the presentation system, here's the image, please use it to display the Windows contents. And that operation is called present. So we can do that. We can try to do that. Let's try to do this. So to do the first thing, you need to do vk acquire next image. So this says, given a swap chain, please give me an image, or rather like an index, that we can use later. So you need device, you need a swap chain, you need timeout. Is there like a timeout infinite? vk no timeout. Come on, IntelliSense, work with me here. Okay, basically, I don't know what the spec says here. Now we need a semaphore. I think fence can be null. I might talk about this stuff later, but if I talk about this stuff now, we will definitely not get this done. So I'll just ignore this for now. I think I need either a fence or a semaphore. So we'll use a semaphore. A fence would be easier because reasons. Okay, yeah, let's do this. All right. Okay. Due to the abundance of the create infrastructures, it probably is a good idea when you write Vulkan code specifically to just immediately move things like this to functions. And again, I think this C++ wrapper makes some of these things less painful, but it also makes compiling my code more painful. So I don't want to go into this land of C++ stuff just yet. I don't think there's anything useful here. Like in some other languages, you could imagine that you can do like this, whatever. Like that you can just have a struct literal and then take a pointer to it and then just use it. Don't think in C++ you can take a pointer to a struct literal. So, alright, so I want a function to create a swap chain, and I want a function to create a semaphore, because this is getting unwieldy. Oh, and family index. I might cover the Q family on the surface. Oh my. I might cover the Q family stuff on a subsequent stream. Definitely not now. Come on. I'm hitting. Oh, okay. I'm accidentally hitting the Windows scheme. And let's just do semaphore. Fine. All right. It's kind of unfortunate that you have to. This is why. So somebody was asking about VK easy. So the not nice part about Vulkan is that to get to interesting bits that I actually want to talk about on stream, where did my create info go? I think I erased something I shouldn't have. Okay. To actually get to the interesting parts, you need to wade through the non-interesting parts. Now, I could just take a framework, right? But then you would not be learning how to write Vulkan code from scratch. For some of you, it might be interesting. Structure type semaphore, yeah. But this is why frameworks like vk-easy could be good, because they let you skip all of the stuff that honestly isn't super interesting. I mean, it's interesting occasionally, but it's not that interesting. And then just get to the fun stuff. All right. So yeah. So now we have a semaphore. The semaphore is used as a synchronization mechanism. So when we call this function, it says, here's an image index that you can use in the future. But its use is conditional on the fact that the GPU stops using this image before you start using it again. And the way how you know when it stopped is you use the semaphore. So this is why you need the semaphore. And to present the image, you need to, to render the image on screen, roughly speaking, you need to call this guy. So for this, we need a queue, which we don't have yet. And also we need present info, which we really don't have yet. And I anticipate a problem with all of this stuff, because I might, I might need a command buffer already at this stage, which would be slightly painful, but okay. Yeah, so let's see. This is a different semaphore. I don't think I will need this later, but I don't need this now. So we will not fill this in. You can present more than one image. For example, in the stuff that I do at work, like I work at Roblox for people who don't know, and we have an editor. The editor has windows, and many of these windows are rendered with graphics APIs, for example, Vulcan. And for that to work, you have to present multiple images, and we do this with this. So there's a reason why you might want to say swap chain count to be 2 or 3. This is when you have multiple windows and you want to just render into all of them at the same time. What is this? Interesting. I've never used that. All right. So we don't have a queue. So the queue is the thing that you submit work to for GPU to work on it, and this is where this is what this family index was about. So if you have like a graphics queue and a compute queue, graphics queue might have a family of 0 and compute queue might have a family of 1, but we only use 1, and I don't remember how you get a queue. Get device queue. All right. Device family index queue index. I really hope validation layers won't complain more about this stuff, but all right. So I suspect this will not work, or I suspect this will fail validation. But let's see if it even compiles. Oh, right. It emphatically doesn't work. It crashes. Oh, I forgot to do device wait idle. Which might be a problem, but might not be a problem. Alright, let's see what it wants. Alright, so... Oh. Oh. validation layers crashed. Nice. Okay, let's... That was interesting. This is not a problem, but probably, but I will do this anyway. Yeah, that's interesting. So the reason this is also not going to help, but the reason I want to do this here for now is because normally you have to deal with some complicated synchronization mechanics when you want to run GPU and CPU in parallel. And here I will just wait for GPU to complete everything that it's doing to not have to deal with this. But the code will still crash. So we are crashing inside validation layers, which is not fun. Generally, validation layers aren't supposed to crash. They're supposed to tell you what you're doing wrong. So that's not great. What? Wait. Come on. So yes, I'm passing it a pointer to the image index. It gets a pointer from the driver. It gets a value from the driver. The value is 0. And then it performs some validation checking. And then it wants to see, but there's no Alright. I mean, I can't like blame the validation layers because nobody should write code like this. Because we are writing code like in small pieces, right? Like this code doesn't work yet. But yes, I think what happens is this. You're supposed, so we are dealing with an image index here. But this is just an index, it's not an object, right? So you're supposed to get objects from the swap chain that are indexed with this index, right? And then like use them. But if you never do this, my guess is that the validation layers don't initialize some code that is like important and then crash. We'll file a bug on this if this is true. So my guess is that if we do vk get swap chain images, which says given a swap chain, give me the images that you have, and then my guess is that the crash will go away. But it's kind of not ideal that you have to do this. So there's that. And yeah, we will do our usual Normally you need to ask the swap chain how many images it has and then create some sort of dynamic array, I guess, for this. But this is so not worth our time, so we will not do this. Oh, and we will learn how many images we have. Swap chain images, and this is, how can it fail? There's some functions in Vulkan that can fail, so they return vk result, and there's some functions that can, so they return void. So this apparently can fail sometimes. So let's see if that fixed the problem with validation layers. If it did, we will file a bug. It did. We have a black screen. You can see that we are not doing things correctly. There's like problems here, right? Because, oh yes, this is what I was thinking would be the problem. But hey, Intel drivers don't care, so we won't care for a bit. And remember, we'll clean all of this up later. Alright, so we found a bug in validation layers. Validation layers crash if you call this guy before this guy, because this guy initializes some state in validation internals. Did I specify a queue in the device create info? Yeah, I specified the queue index. It's like 0. I just hard-coded it as 0 for now. So yeah, let's just do this now, because it'll take us a minute. Whenever you have issues with Vulkan, ever, you should file them as bugs. Obviously, validation layers contain bugs for validation layers. There are some other repositories that you should file bugs to if you find one. Yeah, so there's nothing already reported like this one, unless it's been closed. No. Alright, good. So we will say crashes in validation layers if hasn't been called. If you call before calling, which could be potentially invalid if the spec says so, but A, I don't know that it's invalid. B, even if it's invalid, you shouldn't crash, you should have an error. Validation layers crash here. Let's just check where they crash so that we can file a better bug report. Alright, like in right, there is that. I think it was empty, right? Yeah. And then we just dereference it with an index 0 and then we crash. All right, cool. So we have ourselves a black window. We have validation errors. We'll have to fix them, but not today. I want to see if we can get the window. I kind of wanted to spend like 2 hours on this, and we are getting really close, but I really want to see a color that is not black. And I think we can get there pretty quickly. So normally you have to create a few extra structures, like many more extra structures, to be able to render things to an image, and we will try to like clear the image in the sort of least number of operations possible, even though this is not good practice. So we will try to say that once we acquire the image index, we want to clear the image, and the way we'll do this is with this vkcmd clear color image that emits a clear command. Now for this we need to learn how to emit commands, and I want to see if I can just write this code in like 5 minutes without talking about this, and then have an image, and then answer questions, and then end the stream. And then next time we will clean up the validation issues and actually get a triangle on screen. All right, so yeah, so we need a command buffer. So let's just try this. So the reason why I need a command pool is I need a command buffer, and the reason I need a command buffer is I need to be able to submit commands. What? Okay. So command pool isn't managing commands. Command pool is managing command buffers. So it really should be called command buffer pool. But what can you do? And when I create it, I need to specify like which queue I will be using to submit these commands to. Oh, and also I should probably be destroying some stuff. All right, let's. All right. There's that. And then let's just destroy a bunch of stuff that we forgot to. Validation layers should actually track memory leaks. So maybe let's not bother doing this and let's clean this up later. All right, so what we need to do is we need to reset the pool so that we can use it, so that we don't like leak memory. And remember, so we are waiting for GPU right now. We are like recording a frame, submitting a frame to GPU, waiting for GPU to be done with this, and then do the next one. When you are not doing this, and we will not do this at some point in the future, you need more complicated code. But for now, the code will be simple. All right, so now we need to allocate a command buffer. Just one. There's a lot of code. I kind of forgot how. No. I kind of forgot how much code it was, because, like, I mean, we have a Vulcan renderer at work. A few people wrote it. I wrote parts of it, and then it like works, and then when it doesn't work, you like fix it, and you kind of don't worry about this stuff because you've already written this code. Turns out writing this stuff from scratch is not. Like, it's been, I mean, I haven't been just writing code. Like, I think if I was writing code without talking, which would not be very fun, then I think I would have had a triangle. I think I would have gotten a triangle on screen. But it's still, like, not very good. Even though, so OpenGL is more verbose, but like in modern OpenGL, you still have to allocate a lot of stuff. Like not allocate, like prepare a lot of stuff. Oh, I can allocate this thing once, and then I can just reuse it because reset command pool should make it usable again. All right, so begin. One thing that annoys me about Vulkan is these endless structures that you have to fill, and like the fact that they are present. It's not like it's very hard to fill them, but this turns every single function that I want to call into like multiple lines of code. And there is a reason why they do this. It's to make extendability easier. But this, right, there is like a function with two input arguments, flags and inheritance info, and both of them can be 0, I think. Well, this should really be this for performance, but like, and I need to spend like 3 lines of code instead of 1 line of code, and it accumulates. Does this return? Yeah, okay. Alright, so then we will end command buffer. Also IntelliSense is really slow, it's kind of interesting. It looks like it takes it a while, even with C headers. I'm glad I'm not using C++ headers. Alright, finally we can record a clear. We will have validation errors. We are not doing things well, or we are not doing things right. And I will not bother unless the code just doesn't work. And we'll talk about this stuff later in the next stream. So we need an image, layout. Let's just pretend it's like, I don't know, general or something, I don't care. We need a color. We need a range. Okay. Okay. Hopefully this is just for floats. Oh, it's a union. Okay. So yeah, let's see if we can clear the screen. And then there was like sub-resource range. This guy. I'm not. Come on. So yeah, I'm ignoring some parts of the, like I'm not explaining some parts of the code that I'm writing. We will do this next time if we rewrite some of this stuff to be less obnoxious. Command buffer. Alright, and then the other thing that we need to do is we need to submit this command buffer for execution. And you know what we need to do for this? We need to fill a few more structures. It's amazing. And we need a fence. Do we really need a fence? I don't think we need a fence. I hope we can not use a fence. I think we can not use a fence here. Like, the nice thing is that when you know what you need to write, the code kind of writes itself, plus or minus validation errors. The not nice thing is that it takes a lot of code. So this is actually important. So when I talked about this, when we called this image, we passed it a semaphore, and this image returned us an image index. But the GPU might still be using this image. So we can only really use this image once the semaphore is cleared. This means that if we run the command buffer that clears the image before the image is done, like before the GPU is done using it, weird things can happen. So we need to make sure that when we give commands to the GPU, we say, hey, don't run the commands up until the semaphore, this one, is ready. And also we need this thing, which I will talk about next time. And we're not doing some of this stuff correctly anyway, so mid-stage mask. But yeah, we need to wait for this guy. This is like a very tricky. Things that have to do with synchronization Vulkan are very tricky. This particular thing is really, really, really tricky. It's so tricky that there is a Kronos Vulkan docs repository and has a wiki pages that only has one page that's synchronization examples, and it's a long page, but it's not that long, I guess. And one of the things that they tell you how to do is to do this thing somewhere. I don't remember where. It should be like presentation. Yeah, so swap chain image acquire and present. So really you should be like looking at this code and then using this code. But we pretend that we know what we are doing, which is not true. But we don't care for now. So yeah, we say that we want to submit our command buffer. Yeah, okay, I need a second semaphore. Let's just do this now, because I will forget later. So there's two things. One I just talked about, where you have to wait for the GPU to be done working with the image before you render it into it again. The other thing is that you have to wait up until our commands have finished executing, like after we have cleared the image, before actually showing the image on screen. To do that, we need to, when the image is done, like processing, we need to say that we need to signal the other semaphore. Signal, and I'll draw a diagram of this if this works, and if it doesn't work, then I don't know. I call it release semaphore. And then when you are rendering this image, or when you're like displaying this image on screen, you have to wait. Yeah, you have to wait for it to be done rendering. So we haven't even like rendered a triangle, and we had already had to deal with synchronization in two places, and this is despite the fact that we are waiting for the GPU after every frame. So that's gonna end well. Let's see if this works. If this works, then we are done, and if this doesn't work, then it's gonna be painful. All right, so there is a lot of validation stuff that we have been ignoring. Some of this validation stuff is super legit, and like the fact that the code is working right now is sort of accidental. Like it will not work on a different GPU potentially. But it's been a while, so this seems like a good place to stop the stream. So let me quickly draw this picture with the acquire release, and then I'll look at the chat, and then I'll answer questions, and then we'll end the stream. So yeah, so what happens is this. So first there's acquire, and there's kind of two timelines. There's the CPU frame and the GPU frame. So on the CPU, in our loop, we say, hey, here's the index, right? But the GPU might still be using, let's say we got 0. The GPU might still be using this index for previous frame. For example, to display this image on screen. So display 0. This means that, and then we are saying, okay, let's do clear, right, with index 0, and then let's do present. This is one submission. This is like when we say, what was it? When we say vkq submit for the command buffer that contained this clear command. This is when this clear command goes to the GPU and can start running there. But see, in this case, if we start running it like here, then the GPU is in process of displaying the image, and we will try to clear it during that time, and then maybe you'll have tiering where part of the image is cleared and part of it isn't, or maybe the GPU will just crash because there's some memory controller issue with concurrent accesses like this. So because of this, the clear says that there's a dependency. So acquire says that there is a semaphore that we have called acquire semaphore. And the GPU knows to signal the semaphore once it's done. So here it will signal acquire semaphore, which is when this thing can start running, because this thing is waiting for the acquire semaphore. And then the same thing happens later. When we say present, if we were to immediately submit the command to GPU like this, then it will start running before we have even finished clearing, I guess, right? Especially if it's a different queue. But even on the same queue, there are some cases where present may start running before all clear operations have completed. So instead we are saying that on GPU there will be a clear, and then it will signal the release semaphore, and this is what this code is doing. And then we are saying when present executes, or like to execute present, we have to wait for the release semaphore, which is when essentially display will happen again, right? And this is what this code does. And yeah, so this code is almost correct. There is something like around here that's not correct that we'll deal with next time. But hey, the code worked. It rendered a beautiful magenta image in the window. It also has a lot of validation errors. All right, let's look at what chat thinks. Yeah, tough first steps. Yeah, so I was kind of expecting we will not get to a triangle, because to get a triangle I have to compile a shader, 2 of them. I have to create shaders, which is like 3 new objects or something, and then I'll have to create a render pass and create a frame buffer and a bunch of, well, and I guess that could be it. I don't need buffers. Yeah, so but then I also have to clean up validation errors, right? And then I don't want to just gloss over like everything that I was doing in the last 10 minutes or 15 minutes. So that will be a subject of the next stream, where we'll clean up the validation errors and actually render triangle on stream. Alright, have I considered using C99 designated initializers for VK structs? Yeah, so the problem is C++ doesn't support this, which means C++ compilers basically don't support this in C++ mode. I think it's a feature in C++ 20. Yeah. Oops. Wait. Yeah. So C++ 20 will include support, limited support for C99 designated initializers. I don't find them that much shorter, I guess. They basically remove like this stuff and allow you to do something like this plus this, right? So it's slightly shorter, but also whatever. Like, this is not why this code is painful, it's because you have to fill a lot of stuff out. Let's submit the code while it works. I mean, it has validation errors, but it works. Yeah, where did... Okay. Why doesn't it show... Oh, what? Oh no! Is this amazing Visual Studio thing that somebody was tweeting about? Oh. Visual Studio. So this file is encoded in UTF-16. I don't even know. Okay. Oh, and we committed this as UTF-16, of course, because it was encoded as UTF-16 in the first place. Okay. Wow. Let's fix this first to have a diff. Should I like file this as a bug right now? Let's file this as a bug right now. Because seriously, Microsoft, this is insane. Like, why does it create new CPP files with UTF-16 encoding if there is no reason in this world to have a CPP file in UTF-16 encoding? I didn't even have Unicode there in the first place. Like, this is just insane. Oh my god. Oh my god. Like, seriously, who came up with this? I think I didn't even realize I would ever see this. I was like, yeah, whatever. I think somebody complained about this on Twitter like a month ago or so, and I was like, yeah, this is really weird, but whatever. It's probably some like weird wizard in Visual Studio that we ended up using. And then I hit the same problem. All right. Yeah. Like, you should not use UTF-16 ever, but especially not for files. This is like, oh, and all right. So let's fix it in Vim. I forgot how to do this. Like this. No, I mess it up every time. ++enc. Yes, ++enc. And we saved like a weird file somewhere. Okay. That didn't help. That made it worse. Alright. Okay. And now it has a bomb. Why does a Vim... Oh, there was a bomb, so it saved the bomb. Software is broken. Okay. How do I disable bomb? Really? Really? No bomb. Like, it makes sense that it, I guess, sort of makes sense that Vim kept a bomb because there was a bomb in the UTF-16 file, but this is like, all of this is so broken. Okay, all right. So all right, now let's unstash the stuff that we have done. Sure, whatever. And then repeat this process, right? Because now, well... Don't tell me this will be not fun. Alright. No. Oh, this will be incredibly unfun. Let's see. Yeah, so why does it... Oh, it says can't merge binary files. How can I force it to merge a binary file? Computers suck. If it turns out that we've just lost the stuff that we've done, this will not be fun. Yeah, so it should... Should I just check out theirs on search? No. Maybe the stash didn't work. Oh my god. Alright, great. Alright, I will figure it out after this. I don't know what happened. Binary files suck, Visual Studio is horrible. I will figure out what happened offline and like restore this stuff, and then check this code in after the stream. But this was like ridiculous, right? Like why was this file UTF-16 to begin with? Like this is just insane. Visual Studio's really messed this up. Alright, cool. Yeah, so if there's any other questions about the stream, I can answer them right now. If there is nothing, then we will end the stream, and then I will figure out. I think the changes are there. They're just like in Vim and Do history or something. Like I'll have to figure out where they went, and then just submit them in the correct encoding this time. So it'll close this, file this bug. Yeah, we popped out. That's what happened. Alright. Yeah, let's just end the stream, I guess, because I don't think, let me just scroll back just to make sure I haven't fixed anything. Haven't missed anything. Right, yeah, so I will fix the stream resolution for next time. I think it might be that... oh, actually, wait. How come... Hold on. Oh, yeah. So I will fix this thing. Next stream will be 1080p. Life will be good. I think we might do the next stream tomorrow, same time. I'll double check. I think we might do maybe an hour earlier would be better. Yeah, I think we might do next stream tomorrow just to sort of get the triangle done and, you know, claim victory on that part. So yeah, tentatively tomorrow 10 a.m. I'll post a Twitter update. Alright, thank you for watching the stream. We have written Vulkan code, we've cleared the window to magenta, we have hit a lot of validation errors, and most of them are legit. We've hit a validation error bug and reported this, and we've also hit the crazy Visual Studio binary UTF-16 issue. This is just insane. That I've reported, hopefully they will fix it. I've reported some other stuff to Visual Studio, and they have generally been reasonable about fixing stuff. However, it's not always super fast, right? Like, I think this thing is still not fixed. I guess I reported, well, no, that's unfair, right? Yeah, I reported this and then they closed it and then I had to report it again. But yeah, so who knows when they will fix stuff. They did fix this issue. So that's good. Alright, thank you. See you guys next time. Let me kill